We know that every field is drastically different, from varying soil types to changing topography. Applying the same amount of water across your field doesn't always make sense. With Valley VRI, growers can improve input efficiencies by applying water site-specifically to account for these differences. So you generate greater productivity from all your acres by irrigating more efficiently without compromising yield potential by over or underwatering.
What happens when agriculture goes high-tech? Farmers using what's known as precision agriculture can harness the power of science and technology to improve their land's productivity. This can be done in many ways and at any point in the process. But most farmers begin by collecting data about their own farms. For example, smart combines can detect differences in yield among fields while harvesting. Soil maps can reveal the soil's structure and chemical properties. And mobile weather apps can provide short and long-term forecasts. Computers then analyze all this information and help farmers decide how to make each field as productive as possible. Once the farmers have their analysis in hand, they can put it to use. GPS-guided systems help steer machinery, reducing seeding and spraying overlap to less than an inch. Variable rate technology places specific amounts of fertilizer and pesticide on each part of a field. Monitors and other sensing technologies, such as drones, track field conditions. So what do farmers stand to gain? Well, by using guidance systems and variable rate technologies, small farms saw an average gross annual benefit of $11,000. Typical size farms stand to gain even more, and large farms reap the greatest return with the technology paying for itself in less than 2 years. A pretty sweet reward after a hard, high-tech day's work.
How will farmers be able to feed 1 billion more people? Or 2 billion more? Smart farming using intelligent connected devices can help them to make better use of water, spot diseases and prevent them from spreading, automate cultivation, and use data to increase yields. And that's all possible today with the Internet of Things. In fact, the use of IoT techniques for farming has the potential to boost food production by 70% by 2050. IoT is changing the game.
The tractor revolutionized farming across the world. Today, the use of data is having a very similar effect. With cultivatable land in decline and demand for food increasing from developing countries, farmers who use data are capable of turning ordinary harvests into bumper crops and profits. Behind this is the Precision Agriculture Hub, connecting the world's biggest agricultural businesses, farmers and suppliers, using integrated software solutions from SAP, the in-memory database SAP HANA, and First for Farming's network and supply chain to make better informed decisions. This includes which crops to plant, which fertilizers to use and how much to apply, and what crop protection prescriptions they'll need to maximize yield from every field. Here's how it works. Jeff, our farmer, has logged on to the Precision Agriculture Hub. In the past, he was worried about his privacy and the security of his data. However, because the Precision Agriculture Hub is neutral, any doubts he has over entering his data are eliminated, as the information is only used to help suppliers provide accurate prescriptions for seed, fertilizer, and crop protection. His request goes out to his suppliers. Using analytics powered by SAP HANA, they respond in real time, suggesting different seed mixes, fertilizers, and crop protection prescriptions to help him get more from his land and optimize his costs. Deciding what to plant, Jeff uses the prescriptions to look at seed type, resilience to disease, spread per meter, which fertilizers to use, and where to use them depending on type of soil on his land. He also analyzes weather data and cross-references market prices before making his final decision. A few weeks later, Jeff sows his seed, fertilizes his soil, and sprays his crop with the optimum amount of protection needed per square meter, maximizing yield using GPS tracking technology. A few months later, Jeff's crop is mature and ready for harvesting. his calculations were correct. The market has moved in his favor, and his decision to use the Precision Agriculture Hub is about to pay off. And he's not the only one who's happy. His suppliers have benefited too. With new levels of trust and a better understanding of Jeff's business, they're able to help him in other fields of business.
What if there was a device that was able to do the planting for you autonomously? 24 hours a day, while you can monitor the progress conveniently from your home, office, or wherever you are. A device that precisely took care of every single plant to leverage sustainability while saving energy, time, and money. Introducing Mars, the mobile agricultural robot swarms. How does it work? Select a field on the Mars app. Adjust parameters like seed type, seeding pattern, and seed population, and select the number of robots you are planning to use. After defining the position of the logistic unit, Mars automatically plans the whole process and calculates the needed time. Locate the Mars logistic unit next to the field and press Engage. The robot team will now accomplish the planting autonomously. Due to the small size and light weight, Mars robots are inherently safe, and soil compaction is negligible. The cloud-based system maintains a geo-referenced record for each seed. Each of the robots is connected to the Mars cloud where all data is processed, while the Mars app allows progress monitoring from any mobile device. The supervising control system makes sure every robot returns to the logistic unit in time for recharging and seed refill. In case of a malfunction, Mars automatically recalculates the mission on hand, and other robots of the team will step up to get the job done. Imagine the possibilities of Mars. Use just a few robots for small fields, or employ a big fleet for large-scale agriculture. All the data Mars provides is easily available for further analysis and improvement of the crop production process. Knowing the exact location and seeding time of each plant enables a geo-referenced record from seeding through crop care to harvest. Supporting a plant-specific and exact supply of water, nutrients, and plant protection takes precision farming to a totally new level. Productivity and sustainability for the farm of the future. This is Agriculture 4.0.
Adam has a busy day ahead. He checks the weather forecast and task reminders on his iPad. As a plot is ready for replanting, he receives advice on how to ensure the most efficient and sustainable crop. He views a yield forecast and costs. Using this data, he checks the order against his existing inventory before submitting it. As Adam gets onto his tractor, a servicing notification pops up, along with a suggested date to minimize disruption. While making his rounds, he sees a worker who is unwell and quickly reassigns his tasks. Next stop is the barn to check on stocks to be sold and their prices. He adds the forecasted income to his financial balance. As the stock level is ideal for collection by his distributor, a request is automatically sent. Adam's corn will be on the market tomorrow morning. Finally, a phone notification pops up. Rain is predicted tomorrow. He adjusts the sprinklers in advance so less water is distributed to the crops. With a little help from SAP technology, Adam makes better farming decisions that benefit his workers, land, and crop.
The soft robotics gripper doesn't require any feedback systems or force sensing, greatly simplifying the difficult challenge of grasp planning. Additionally, the system uses FANUC's 3D area sensor to locate each individual apple for picking. Once the FANUC robot locates the apple to be picked using the 3D area sensor, it can grab it in any orientation. No other information is required, as the soft robotics gripper does not need to know the orientation of the apple, nor where it picks it from.
Pick and Pack. Pick and Pack consists of several smart modules, each with its own important function. It all starts with the so-called flexible thermoformer, which is what determines the exact dimensions of the packaging. With its flexible mold system, the shape of a mold can be changed in under a minute. It's as easy as playing with Lego. The form of the mold can be adjusted to fit the size and shape of virtually any product. As the plastic is molded, the RFID scanner examines the crate to establish where and when the products were harvested and sends this information to the line controller. Next, the Pick and Place robot gently picks complex natural products from the harvest crate, taking away the need for a conveyor belt. Its vision-controlled robotic gripper, specially designed for careful food grasping, is then automatically cleaned in the robot cell. After picking the product, it's time for a quality check, performed by a so-called Quality Assessment System, or QAS. It uses a variety of sensors, which together tell you the weight and the bricks of each piece of fruit. Even in a truss, this self-learning system can check for both surface and internal defects. With the quality of the product established, it's time to give it a personalized print. Thanks to the flexible printer, there's no need for labels or pre-printed foils. The package's exterior, as well as its final destination, can be determined at the very last moment. The laser sealer cuts the packaging into any desired shape, as well as sealing it. Its lower energy consumption helps prevent overheating of the factory. A packaging audit is also included, equipped with an infrared camera to check the integrity of each seal. It enables immediate resealing when necessary. Next, each package is provided with an RFID tag, a small antenna that makes it possible to track and trace the products. Now that the product has been checked, printed and sealed, it is time to sort it according to quality and destination. The beautiful thing about this innovative sorting system, called Pickable, is that it hardly uses up any floor space, despite its large flexible range. The surfaces of the Pick and Pack line never have to be cleaned by hand. Instead, an adaptive self-driving cleaning robot treats each module according to its specific hygienic status, making sure the entire system is left spotless for its next use. What truly crowns this master plan is the fact that the graphical user interface makes it possible to approach each separate module independently. The modules can be used in all sorts of different configurations, and adding a different module is easy to do, no matter which vendor or software language is used. The software is specifically designed to set up a collaborative line, ensuring that the different components always act as one.
AgroCube is a hydroponic unit developed by Daiwa House Industry. AgroCube utilizes unique technologies, including the variable height illumination system, which can provide a specific amount of light for cultivation, and the fertilizer circulation and drainage system, which makes cleaning cultivation racks easier. Air conditioning and other equipment is also provided as a package.
The main goal of Nature House is to offer a smart home covering 3 aspects: material, energy, and ecocycle of water and nutrients. Here is how it works. The house is surrounded by a climate shell. The glass house functions as a solar collector, creating a Mediterranean microclimate within the building and protects the living space and crops from weather conditions. The shell responds to the weather by using automated windows that can be opened and closed to maintain a suitable temperature. The plantation in the climate shell provides clean air, shade, fruit and vegetables with an extended harvest period.
Instead of growing plants in big horizontal fields, you grow them in racks stacked on top of each other. Basically, do for farming what high-rise apartment buildings did for housing. Growing plants in towers gives you a lot more production for your footprint. It solves other problems too. Moving plants indoors means they're not at the mercy of weather and other environmental factors like, say, drought or smog. We don't need to convert more wilderness to extensive farmland, and it better controls runoff of fertilizers and pesticides into waterways. Hydroponics is one way to grow plants indoors, meaning the roots sit in nutrient-rich water. No dirt! As a bonus, that actually reduces water use. One study found that hydroponics produced more lettuce with 90% less water. There's also aeroponics, where the roots get sprayed with a mist of that nutrient-laden water. Aeroponics uses 70% less water than hydroponics. However, you need more than water to grow plants indoors. When it comes to vertical farming, the energy use can be much greater than horizontal farming. Climate control systems, including air circulation, water pumps, and sensors, all require electricity.